Good Tuesday evening to you. This is the severe weather update for tomorrow across the western Carolinas, well, the whole state of North and South Carolina, and generally the southeast. We're going to start out here with a majestic view of this storm system. It's huge. It takes up a lot of real estate. A couple of things you can see on this loop is the storms across the deep south and southern Mississippi River Valley, as well as this what we call a calm ahead mid-latitude cyclone with some dust across Texas. And the winds out here are causing some big problems with fires. But our focus here will be the severe thunderstorms. And note as the sun sets here, that's what this is. This is the setting sun. You can see the satellite turning over to IR or infrared imagery as the sun sets across this part of the earth. Cloud cover is pretty much the name of the game across the Carolinas. So let's get into some of the forecast models right now. We're going to take a look at the NAM first. This is the 850 millibar level winds as the storm system approaches. I mean, these winds are screaming. They are upwards of 60, 70, 80 miles an hour. Here is 86.3 miles an hour across central North Carolina into the foothills of North Carolina. That is some wind right there. And what this is going to unfortunately do is going to be brought to the surface as this line of storms crosses the Carolinas. So we're going to take a little bit more of a high resolution aspect of this. We're going to go to the 3-kilometer NAM. This shows at approximately 4 a.m. a broken line of showers and thunderstorms with some embedded bowing segments with that wind that you just seen going to be brought down to the surface from these updrafts. And across the western North Carolina mountains, some very heavy rain, some very strong winds are possible as this line makes its way eastward across the state. So as the line comes east of the mountains, I am expecting it to regain some organization. Generally, when storms come across the mountains, you have some of these storms breaking up, and that's going to be the case in this situation. And sometimes they reorganize as that front is creating a very strong forcing mechanism. So I would expect some of these storms to reorganize as it makes its way across the western foothills of the eastern foothills of North Carolina into the Charlotte metro region. This particular model run, the 18Z NAM, 3-kilometer NAM, is a little slow with this. This is just getting into the Charlotte region at about 10 a.m. And then making its way. So from earlier runs of the model that we saw yesterday, it has slowed a bit. I'm getting some conflicting information because right now the storm system is in south central. Well, the vast majority of the severe weather is in south central Mississippi. And some of the models are forecasted to just now be getting into Mississippi. So, or maybe an hour or so ago. So the leading edge of the system is ahead of the models. However, the NAM has slowed down. This might be because the system is wrapping up over the Midwest, or for whatever reason it has slowed it down. Now, if we take a look at some of the other models, the HER and the GFS and the RAP model, you can see that, this is going to be on the slow side. So we're going to go over here. We're going to go to current models. And here's the NAM nest. This is the 3-kilometer NAM. This is at 9 a.m. getting into the Hickory region and Shelby and points southward. We switch models. There is the RAP. Now the wrap at 9 a.m. has this line of thunderstorms in Winston-Salem, Greensboro region, now east of 77 towards the Albemarle and Monroe regions across North Carolina, getting into some Lancaster County in the upstate South Carolina. And this is the HER model. This is the latest HER model. And here is a very thin line of showers and thunderstorms in the HER model. This is the front. And this is the precipitation behind the front with the weak echo channel, which is a pretty solid signature of a strong line of thunderstorms, at least on the observed radar. But now that we can kind of forecast what the radar looks like, you can forecast this weak echo channel. And then, yeah, so you can see that the two models that are listed here, the HER and the RAP, are faster than the NAM-NES. So sometime tomorrow morning between probably 7 a.m. to 10 a.m., the showers and strong thunderstorms will affect the Charlotte metro region sometime during that time frame. Now, as we go a little bit further, we lose the HER model at this point, at least the latest run of the HER model. We'll have to go back to the 18Z HER. But as this line shifts eastward across the state of North Carolina and South Carolina through the afternoon, so we're sitting here at, this is 2 p.m. here. You see these little these little red blobs, these blotches. These are probably going to be supercells, or at least act like supercells, because it's such a strong wind shear in this area. So we'll take a model profile. Let's do one here just ahead of the line so we can not get any convective precipitation or convective contamination in the profile. But because of the winds, the kinematic, we talked about this yesterday, is so strong, what we're lacking still is the instability. Now the trend has been upward, but still you're only looking at about 500 joules per kilogram of mixed layer CAPE, and mixed layer is actually the best indication of how unstable the atmosphere is, and it's less spatially variable, but we're still lacking in the instability. But if we take a look at this model profile, look at that curvature on that photograph. The more curvature, the more low-level wind shear, and you can see it in the wind barbs. And a weak tornado is the potential hazard, but that's just a potential hazard. This thing is still in the winter mode. So here is what our analogs have. Still it's pretty lackluster in terms of the thermodynamics, only about 231 joules per kilogram here, only 6 kilometer of 3 CAPE, 3 kilometer CAPE, or 6 kilometers, 6 joules per kilogram of 3 kilometer CAPE. So the thermodynamically it's still lacking, which is good, because this just means that the thunderstorms will need to be forced, and there's not going to be any thunderstorms that are going to be bubbling up ahead of the line. Those are the ones that you want to watch out for. The storms that bubble up ahead of the line. What in this kinematic environment, this is that would pretty much be a very large tornado threat out ahead of the line. But since the atmosphere requires forced convection, we'd have to watch the line itself. I don't really see, unless something drastically changes, I don't really see too much in the way of supercells out ahead of the line affecting the eastern part of the North Carolina and South Carolina coastal regions because of the lackluster thermodynamic profiles that we are seeing in the models. Again, more of a tornado threat out east as the atmosphere does become slightly unstable out east. The western part of the state, pretty much west of I-77, is pretty stable, although because there's no thermodynamics involved with the earlier stages of the storm system out in the western part of the North Carolina and South Carolina, I'm not really looking for anything too bad, except for some very gusty winds and just embedded tornadoes within the line. The tornado threat becomes more prominent as you go eastward because of the introduction of instability out east. So that just about does it for this video. You guys stay safe out there. Be weather aware. Have your NOAA weather radio. Be close to your favorite media source. And as always, watch out for the National Weather Service warnings, because there will be warnings tomorrow, probably even tomorrow morning, for wind gusts in the western parts of the Carolinas. But you guys stay safe and have a good one. I'll see you in the next one.